Today we continue with story about Enterprise Java Beans, and we will be doing showing how to integrate Java server faces and JPAs, and also talk about session beans regarding the EGB3s. So, what we learned is, okay, so you know about Java persistence APIs, you know how to invoke entity persistence from standalone clients, and also you know how to invoke persistence APIs from Java servlets. This is what we did last week. So, talking about, if you remember, JSF's first week, and JSF rely on Java managed beans. So remember that we specified managed beans, and then JSF invoked those managed beans. And those managed beans also is what JPA is relying on. So putting these two together, JPA beans within the JSF managed beans is no big deal, as you can see. It's straightforward. What we need to do is simply, the trick is to annotate JPAs as JSF managed beans. So remember from when we talk about JSFs and managed beans, we annotated this Java code as managed beans. So to make use JSF and JPAs, with JPAs we talked about entities. So we annotated Java code as entity, and then JPA I used to persist those objects, the code as entities. So to put it together, we need to annotate JPA entity as managed bean. So we have two annotations, one to say this is managed bean, another annotation to say this is the entity, and everything else is simply straightforward, which is a piece of code that tells you that. So we have, so managed bean is what JSF requires, and then to use JPAs we specify entity or entity beans, and entity saying, okay, table name is a customer, and last week you saw how to specify tables within the entity, and also specify the columns within the tables that will be created when that mapping takes place between entity objects and the database, and everything else is just same for any other entity. When we introduced Java server faces, we mentioned that JSF uses model view controller principles or notion, and the model here is the data, which is represented as the entity bean or customer in this particular case, and JSF pages are the view as a presentation side of the application, and to introduce the business logic of the application, we need another managed bean, which is the controller bean. So this is where this model view controller comes into place altogether. So the entities are the model part of it, data are represented as the model, the view is JSF pages user side, and the controller is simply the additional managed bean that provides the business logic for this application. So example of that additional managed bean or controller bean is this. So so it is managed bean is annotated as the managed bean, and call it customer controller. So class resources that this bean is going to use. So connection resource specified as JDBC connector as named default. Remember from last week when you specified connectivity of Glassfish, you given the name of the connector in the Glassfish configuration file. And then the data sources, persistence unit, and specify the name of that persistence unit that you're going to use, and then some factory for the entity manager factory, and resources that are part of the application. So the managed property resource is the table customer that is going to be created in a database, and the bean customer object will be part of this application, and have the variable customer will represent that object. So some methods that are needed in this controller. So when the object is to persist, we will need the method save customer method. They will be invoked when user press the save button. So data from the object then are mapped into the table and saved as database records. So we also want to specify what page will be presented to the user once the data is saved. Let's say, okay, customer saved is the return value of that method. You remember first week when we talked about JSFs, we specified navigation using JSFs is determined by the value bean returns. So if bean returns customer saved, then customer saved page will be presented to the user. And in order to make use of entity manager, so we invoke the create entity manager method as a part of the entity manager factory. So do this as the transactional transaction. So calling the begin transaction on the user transaction. So call the entity manager to persist that customer, and once the records are saved, we need to commit that transaction. Simply invoke commit transaction, and database will release transaction. If this is a try and catch block, if anything goes wrong with the catch block, we are saying, okay, so the return value from that bean will be error saving customer. So if everything goes fine, is the customer saved value will be returned, and page customer saved will be shown to the user. If something goes wrong, data will not be saved, then the value error saving customer will invoke that page, and this is what customer is going to get and return that value to the JSF framework. So invoking that save customer method from within the JSF. So this is just example JSF that uses that, call it save customer .xhtml. Then we have command button element with the action. So when the button is pressed, the action is that customer controller bean to invoke save customer method. So this is what is going to happen, and the value is saved that is passed on to controller bean. And this method so returns the string. We specify the string as the return value. So if data is saved successfully, then customer saved is returned, or error saving customer, and accordingly to this value the web page will be invoked, and user is going to get either customer saved or error saving the customer to run that JSF page. So you simply invoke save customer.jsf, as we already know. So this file is XHTML file, but we invoke it as .jsf. So we never invoke JSF pages as XHTML, always as JSF. So that was showing how to integrate the JSF and entity beans that make use of JPAs. Moving on to EJB3. So EJB3s are enterprise beans that used to provide the transaction element of enterprise applications. So entities are used to provide persistent aspects of the application. So the session beans are those that will provide transactional aspect of application. And because they are EJB3, already mentioned last week, we do not require use of XMLs to specify description how the EJBs are invoked. So all that, so regarding the entity beans, regarding the other EJBs like session beans, it's all done through the use of annotation. But this is what makes life easy when it comes to development and deployment of enterprise application. So the way to do that is to make use of dependency injection. So dependency of injection concept is the idea of providing providing the interface to resources at the moment the bean is deployed. Until dependency injection concept was introduced, resources were allocating when bean was invoked. With the dependency injection idea, the resources allocated the moment bean is deployed, not invoked as before. This is the great advantage of using dependency injection in EJB3. So, so normally, so without dependency injection, we have this situation. So we have the EJB is invoked, and then needs to find the interface to resources, needs to identify resources. So the JNDI, Java Naming and Directories interface lookup is performed, and interface to these resources is returned. So with dependency injection, we have the beans that developed and deployed onto container. Resource is also deployed onto the container, and then when this is deployed, those resources are injected into the EJB. So bean automatically gets that interface to the resource. The resource is found, interface is going to the bean, and then what bean just needs to make use of the resource. So all that is automatic process. So we don't need to bother by making explicit call to look up the resources and then receive the interface to these resources. So with the injection, so container will initialize these bean instances when bean is deployed, when it's made available. So what can we inject with injection, or EJB context, runtime context regarding the EJB. Entity manager could be injected, all the resources that are used, and references to session bean. So if the bean is making call to session bean, then that bean will be found by the container, and then the bean that makes call to session bean will receive the interface to it and is able to use it straight away. That's the whole idea. So you know, in the past, what would happen, you would successfully deploy your application, and then if there's something wrong, you wouldn't find out until you actually try to run the application, get the bean to do the work. Because at that moment, bean will try to find the resource, and if it can't find it, the error will occur. Here, if something goes wrong, it will go wrong at the moment of deployment, because at the moment of deployment, the container will try to find and inject the resource, and if it can't find the resource, you won't be able to deploy, and you get error message, deployment was not successful. So, session beans are the different type of beans from the entities itself. So they encapsulate the business logic, and the session beans are not persistent. We do persist entity beans, but session beans are active only for the execution of transaction. Once application is completed, then it's lost. So the data is not saved when session beans are used. So only entity beans persist the data. And session beans could be either stateful or stateless. Stateless means the session bean will receive request, execute request, and then forget about the client that made the request. With the stateful session bean, then the client will be able to see the status of the transaction, because stateful bean will remember the interaction with the client and remembers the status of the transaction. The session beans make use, they are same as entities, plain all Java objects. So they use plain Java code and also metadata to describe the properties of the session beans. So some callback methods in the form of EJB, X, Y, Z, blah, 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 so will be provided, will be implemented automatically by the container. So developer doesn't have to provide those callback methods. So it can be provided, but it can be left out, and it's container that automatically generates those callback methods. So the classes that needs to be created are interface, so business interface for the session bean itself, and the bean that implements that interface. This is all what is required for developing a session bean. So simple session bean. And so, I said, interface is first thing that's required, and that interface has to be remote, because the session bean will be invoked remotely by the client. So we need to import the libraries that enable remoting of the session bean, and use the notation saying it's remote, and give it name of the interface and methods. Methods that will be part of that session bean. In this, because it's a simple one, we say, okay, this session bean will give us returns the message, and the method will be get message. So this is the interface for this session bean. So next, what's required? The actual body of the bean itself. that would implement this interface. So in this case, we implement stateless session bean, import the stateless libraries, and specify with a notation this is a stateless bean, call it simple session bean, and has to implement the interface that we specified. So implements simple session. So what does the bean do? So simple message that will show up if something goes wrong. So it should say, if you don't see this, it didn't work. So this is the message that the client should see if that bean has been successfully invoked. So the body of the method of the bean is return the message. So when the bean is invoked, that message gets returned and client sees the message. So it is very simple. So we simply hard-coded the message that the bean is going to return. So the role of the container itself. So the container, what does deployment time? So it creates the instance of the bean that deployed, and the instance is made available to client applications. So the client will invoke that instance of the session bean, and this is because it's remotely based client and the bean itself, so it's a remote interface that is returned to the client. So it's not the bean that is returned to the client, it's the actual interface that client receives, and client invokes the bean through the interface. So very often you make mistake by returning the bean to the client and instead of interface. So you have to remember this. So to invoke the bean, you need to use the actual interface data type to invoke the bean, not the bean type. And so it is meant to work across the network. This is why we say it's the remote. But we can specify to be the local. So if it's on a single machine, you can say, okay, it's a local annotation, meaning the bean is implemented on the same Java virtual machine as the client. So we don't have invocation across the network if the bean itself is local. So the simple client, so they will invoke our simple bean with this one. So obviously we need to invoke some EJB library. So client needs to be able to compile EJB stuff, so needs to have access to the EJB libraries, and let's call it session bean client. So the variables object we specify. So simple session is the object that we're going to have, and type is a simple session bean, and we need reference to the container itself. So the initialization time, so the container will be created, so call the create EJB container on that EJB container class that we imported. And for the bean itself, we need to get the context, the EJB context, call the container and then get context method for that particular bean. So notice that we are returning the bean interface itself. So you make here, so what happened, we are making the lookup. So we get the context of the bean and then call the lookup method to find the instance of that simple bean, which is the kind of format of invoking, doing the lookup call for that session bean. So the return of that bean is the interface, and the simple session object receives that interface, meaning the instance has been found. So if lookup returns, the object has received that session bean interface, and once the session bean interface is received, it could be invoked. So the invocation of the bean is calling the get message method of the bean on the simple session object. So simple session object is what it received the interface, may call the get message and print out, for example, in our case, print out that message that has been received from the bean. So because it's this standalone Java code that makes that invokes this session, so we need to have main method of the class. So it is the main method, and create new session bean clients with invoke session bean method. So session bean method that we specified as part of the client. So you don't need method invoke session bean. You can just invoke that within the main method itself. So it's just how you develop it. So it's no big deal. So that was an example of stateless AJB. So the life cycle of stateless AJB is that after the instance is created, then the bean will be in a ready state and be ready to be invoked. Once it has been invoked, so it is ready to be destroyed, will be destroyed. And some methods, like post create and post destroy methods, will be generated automatically by the container itself. So as a developer, so we are not worried about those callback methods. It's the container that takes care of that. So once invoked, execute the task and gets destroyed. That because it's the status. So status is not remembered, and then bean gets destroyed and removed from the memory. Next time that being invoked has to be initiated again, and then become ready, and then will be executed when invoked by the client. So the other type of a bean, stateful bean, so it's not destroyed after invocation. So when it's created, then it's in a ready status, same as the stateless. But once is activated, then it doesn't get destroyed. It simply becomes passivated, and next time is invoked, then it's executed again, and then becomes passivated. So when user finishes with that, when he closes connection, that container will only then destroy that bean, and post-destroy method will be activated and being destroyed. So similar principle as with stateless bean. The only difference is when it's executed, when it does the task, it doesn't get destroyed, gets passivated and ready. It could be invoked again. So it's still in memory and could be activated when invoked again. So this is the stateful Enterprise Java Bean. So example of a stateful session bean. So they are used as data access objects, that type of the bean. So same as the session bean, we need interface and we need the body. So it is remote, interface is remote. Let's call that interface customer DAO, customer data access object. The methods that this bean will implement save customer method, providing a customer object that will be saved in a database table, or get customer, which read customer from the database table providing the customer ID, and then a container find the customer from database table, and deleting the customer. So if you want to destroy that object, delete the customer, and then that records will be deleted from the database table. So these are the main methods associated with the stateful bean. So the implementation of that interface, so we need to import some stateful libraries, entity manager, and persistent context libraries as well. So stateful is a notation saying, yes, this bean is stateful, call it customer del bean, and implements the interface, implements customer DAO. Annotate persistent context that we're going to use, and specify entity manager object, because this entity manager, they will invoke, manipulate that bean on behalf of the customer. And methods that are to be implemented, save customer methods, takes customer as parameter. So if customer ID doesn't exist, you can supply customer ID. If doesn't exist, equals to null, then we create new customer. So we'll be creating new records in database table for that particular customer if customer exists. So else we update that current record, current object in the database table. So either create new one if it doesn't exist, or update if it already exists. So the methods associated with that. So to save new customer doesn't exist. So we call that, specify that method, save new customer, which is basically invoking the persist methods of entity manager for that particular customer. Or to update, for update existing customer, we call the merge methods for entity manager. So either persist for new customer or merge for updating the existing customer. Method get customer, so it returns customer object, we're retrieving the customer, and provide the customer ID. So give it customer ID, and the method itself calls find method of the entity manager. So find that object, giving the customer class, Java code, and the customer ID. So giving those two parameters, entity manager receives the customer, and this is its return to the client. So client gets the object, then can look at the details. If you want to delete customer, so to delete customer, we need to provide customer objects that's going to be deleted. Call remove method for that customer, and records gets deleted from the database, and you can't see it anymore. So, so this entity manager, so it's directly injected into the customer, into the session bean. And in the previous example, if you remember, we had to inject the instance of entity manager factory into the bean. We had to call the JNDI lookup in order to obtain the instance of the entity manager and instance of the bean itself. So the container will give the session bean to a single client. So a single client will get the instance of that particular session bean. So therefore, it's a thread safe. So not multiple clients will get the same instance of the bean. If multiple clients want to use the bean, they need to receive new instance of that bean. So to avoid any concurrency issues. Again, it is a container managed transactions, and if you remember in the previous example, we had to call user transaction begin and user transaction commit after the data has been saved to database. Here, it's the container that manages the transaction aspects of the application, of the bean, so we don't need to worry about transaction begin and transactions commit commands. So that was invoking EJBs from the standalone client. But what we want to invoke session bean as web applications from JSF. So to do that, so we need to simply modify the custom controller, which we used for managing the beans in previous example. So you simply modify that custom controller, and then here we specify the beans that will be invoked for within the JSF application. So for our example, for this case, so we import all the libraries for EJBs and also for JSF managed bean and managed property. So the customer controller that we need to modify, so it is managed bean, say it's a customer controller, and specify is the data access object bean. So it is the customer data access object bean, object is customer DA, and annotate managed property. So managed property with the value is the customer object. This is what is our table in the database, and say customer object is a customer data type. So to save the customers, so have a method save customer specifying return value is customer saved if everything goes okay, and invoke save customer providing the customer object of the customer data access object bean. If something goes wrong, provide the error value, which would navigate to this web page and then return that value to client. And to get the customer, simply return the customer object that we created. We can set the new customer. So the set customer method takes customer object that we created, and customer equals to that customer that we supplied. So that will set the new customer. And in order for this web application to work, so EJBs need to be packed together with client application into the WAR file and simply deployed to Glassfish. Once deployed to Glassfish, then client application can be used and web application can be used. So this is basic stuff about integrating JSF and Java Persistence API, as well as creating EJB session beans, stateful and stateless.